Hi, welcome to this SAP Tech Bytes video series, a deep dive into Edge integration cell installation procedures. This is video part 2, all about HA. In the first video of our series, we went through a basic end-to-end demonstration of the steps involved in installing Edge integration cell in a hyperscaler AKS-based Kubernetes environment. In case you haven't seen that, it is highly recommended that you watch that first. The basic installation we performed is a good place to start for development and your learning purposes. In this second video, we perform a fresh installation, keeping the principles of HA or high availability in mind. And this is something that you would want for your production workloads. Before we actually dive into the installation, we need to understand some of the prevailing SAP BTP concepts on HA, and in particular, those of integration suites. This may be a familiar slide to some of you. It is based on the premise that in a multi-cloud hyperscaler environment, the computation, typically denoted as workers in cloud integration, are spread across three availability zones, thereby enabling a zone redundant setup where it shouldn't matter to clients or senders on which node the processing actually happens. The same distributed setup holds not just for stateless situations, but also when persistency is involved, as you can see depicted here. A primary and secondary distributed setup ensures that there is a smooth failover if necessary. With that background, let's cut right into Edge integration cell. And here, the fact that the deployment is managed by Kubernetes, a container orchestration and scheduling engine, in itself offers many platform capabilities like ensuring the pods are consistent and that it becomes easier for applications like ours running on top to adhere to principles of auto scaling, redundancy, being able to handle node failures gracefully, etc. And some of the things that we will demonstrate now will be around setting ourselves up for multiple nodes within the control and runtime plane. I'm logged into the ELM page at the point where I'm creating a new edge node. After giving this a name, the key aspect to factor in here is that you need to check off the box to enable high availability mode. Remember that this cannot be modified at a later stage. All other settings in the wizard remain unchanged from our original setup. Now at this point, I'll need to upload my kubeconfig file. Let's switch the context and jump over to our hyperscaler account that controls the AKS resources. I'm at the point where I'm spinning up a new Kubernetes service. And here, like I mentioned previously as well, you will need to ensure that the service should utilize at least three availability zones. And this leads to the next section where I'll further need to ensure that the nodes in the pool will need a minimum of 3 counts. Alternatively, if you are recycling an existing cluster, you can actually scale the node pools and set the count to at least 3 nodes. All right, with those changes to the cluster, let's feed the new kubeconfig back to the ELM wizard, and I'm going to pause the video as I run the ELM bridge bootstrapping process and start the deployment procedure. Now that the deployment of the base solution is done, let's start the deployment of the main solution components.
After specifying the virtual host and the key store alias, make sure you set the enable multi-AZ checkbox, and we'll stick to the defaults for the remaining portions of the configuration and deploy. Let's pause the video and come back after all the steps are done. Once done, let's open the Integration Suite application page and head to the Operate menu. Do not pay attention to the error status as we haven't yet configured the key stores yet. The part that I want us to pay attention to is the component monitoring section. What you see here is that the majority of the pods exist in pairs, which is really an indication that it does follow a redundancy HA pattern, and in fact the eventing component exists as a triplet. And if you're wondering why should the Postgres and Redis exhibit only a pod, that's because remember we chose to use the default setting for persistency, which is not the preferred topology for HA anyway. We will talk about mounting external persistency in the next video of this series. There is one another important aspect around the distribution of paths I wanted to talk about, and for that I'll need to bring up my kubectl command line. What you see here is that the pods in the edge ICEL namespace are indeed spread across multiple nodes. And the same is true for the Solus pods in the edge services namespace as well, thereby indeed demonstrating NHA setup. And of course, goes without saying that these are indeed the nodes that are coming in from the user node pool.
So to summarize, in this video, we saw how Edge Integration Cell and the base Edge Lifecycle Management tool can instrument a pod replication strategy based on customers' HA needs. In the next video, we will talk all about setting up Edge Integration Cell with an internal load balancer. See you on the other side.